Hello friends, we have a question on complex number. We are given a complex number and we have to identify various things like argument of the complex number, proving something related to the formulas we have identified in the topic complex number. So let us try to start from the first part. In the first part, it is given that the complex number z n is equals to n square plus 1 plus I. This I means root of minus 1 and n is some natural number. So in the A part and first we have to identify the argument of z naught. Usually any complex number z is of this format I of. So this is termed as the complex part, this is the real part. So when we plot it on a complex plane, this here we plot real part and here we plot complex part. So this is A, this is B. The complex number would be comma B, and the line connecting it with the origin or 0, 0 makes some angle with the real axis. This theta is called as the argument of this complex number. So in the given question, we have to identify the argument of the complex number z naught. Let us try to know what is z naught. So in the question, z naught means n is equal to 0. So when n is equals to 0, this comes out to be 1 plus. So the argument of 1 plus I is the angle. Tan inverse complex part has is coefficient 1 and the real part has coefficient 1. This divide by this, which comes out to be tan inverse 1. So any angle is pi by 4. 45 degree or pi by 4. Now let us move on to the second part. In the second part, we have to identify the expression for the argument of Zn in terms of n. So what is Zn? Zn is a complex number given in the question n squared plus n plus 1 plus I plus I. So this is the real part and this is the complex part. So if we have to identify the argument of Zn, that would be tan inverse the real part. The complex part here is 1 and the real part is n squared plus n plus 1. So this is the argument of Zn. Now let us move on to the B part. In the B, there is another complex number Wn, which is given as the product of various complex number from Z0 to Zn. And we have to utilize this in the part B. But before that, we have to prove an identity which is arctan A plus arctan B is equals to arctan A plus B divided by 1 minus AB. Arctan, or sometimes we also write it as tan inverse. These both are similar thing. So in the question we have to prove tan inverse A plus tan inverse B, that is arctan A plus arctan B equals to, we have to prove inverse A plus B divided by 1 minus AB. So let us start a simple formula. We know tan of A plus B is tan A plus tan B divided by 1 minus tan A tan B. So these are essentially two angles. So we start with tan of tan inverse A plus tan inverse B. So what it will come out to be tan of A plus tan of B divided by 1 minus tan of A into tan of B. Tan of tan inverse A is nothing but A. Tan of tan inverse B is nothing but B. 1 minus A, which is equals to tan of tan inverse A plus tan inverse B. Now taking tan inverse on both sides, so we get is tan inverse of tan of tan inverse A plus tan inverse B equals tan inverse A plus B divided by 1 minus AB. So tan inverse of tan is nothing but angle, that is tan inverse A plus tan inverse B, which will be equals to inverse of A plus B divided by 1 minus AB. This is what we have to prove in the part of the B. Now moving on to second part. Hence or otherwise show that the argument W1 is equals to tan inverse 2. So before moving forward, let us try to identify what is W1. Before that, let us see what is Wn. Wn has been defined as the multiplication of various complex numbers z0, z1, z2 up to zn minus 1 into zn. So W1 will be z0 multiplied z1. And what is z0? For z0, we have to use the formula of zn, which is n plus n plus 1 plus I. So z0 will be n equals to 0, that is 1 plus, and for z1 we have to put n equals to 1, which comes out to be 3 plus I. Multiplying these two, 1 into 3 is 3, 1 into I is I into 3 is 3 plus I, and I into I is minus 1. So this comes out to be 2 plus 4I. So W1 is nothing but plus 4I. Now the argument of W1, as we already understood, inverse of the complex part, which is 4, and the real part, which is 2. This comes out to be tan inverse 2, which is what we needed to prove in the question. Argument of W1 is tan inverse 2. Now in the last part, we have to use the mathematical induction, where we have to prove that the argument of n is equals to tan inverse n plus 1. So in the C, argument of Wn needs to be proved as tan inverse, argument of Wn, tan inverse n. So we have to prove this for all n belongs to n using mathematical induction. So first we would try to prove it for n equals to 0. Then for n equals to 1, we will see whether it holds true for n equals to 0 or n equals to 1. Then we will assume it to be true for n, and using this we'll try it holds for n plus 1 also. So if we are able to do this, we will be able to say that this is always true for any n belongs to natural number. So for n equals to 0, this is argument of W0, which is tan inverse of, what will be W0? W0 means Z0, which is 1 plus I. So it is 1 plus I. So this will be tan inverse of 1, which can be written as tan inverse of 1, that is n plus 1. So this holds for 1 is for n equals to 0. For n equals to 1, this is argument of w1, which in previous part we have identified as inverse 2, which is again can be written as 1 plus 1. So this also holds true. So we know it is holding up for 0 and 1. Now let us assume that the argument of Wn is equals to tan inverse n plus 1 is true for n. Now let us try to prove whether it holds for n plus also. So for argument of w of n plus 1, if you are able to prove that this comes out to n plus 1 plus 1, question will be done. So we have to prove this. We need to prove this using this. So let us start from this argument of Wn plus 1. Now for argument of Wn plus 1, what is n plus 1? This is nothing but z0, z1 up to zn into zn plus 1. So this is nothing but up to zn plus 1. So we can write this as up to zn, this can be written as wn into z plus 1. We can write this as this. So this will be argument of wn multiplied by gn plus 1. Okay. Now we know that argument of z1 z2 is nothing but z1 plus argument of z2. This is the property of complex number, that the multiplication, the angles get added up. So this will be argument n plus argument of en plus 1. Now the argument of wn, we are already know, we are assuming this to be true. So this will be tan inverse n plus 1. And the argument of zn plus 1, what is zn plus 1? Zn plus 1 is, what is zn? Zn we know is n square plus n plus 1 plus I. So zn plus 1 would be n plus 1 whole square into n plus 1 plus 1 plus I. So the argument would be tan inverse 1 divided by n plus 1 n plus 1 plus 1. Now in the previous part we have proved tan inverse A plus tan inverse B comes out to be tan inverse of A plus B divided by 1 minus A. So this part, further simplifying this, we can say this will be tan inverse of A plus B, that is n plus 1 plus 1 divided by plus whole square plus plus 1 1. So utilizing this tan inverse A plus tan inverse B, we have already proved in the previous part that tan inverse A plus tan inverse B is nothing but tan inverse of A plus B divided by 1 minus AB. So here also we can write this will be tan inverse of A plus B divided by 1 minus n plus 1 multiplied by 1 by n plus 1 square into n plus 1 plus 1. This can further be simplified as tan inverse n plus 1 divided by n square n plus 3 divided by 1 minus n plus 1 divided by n square plus 3n. This can further be simplified as tan inverse n cube plus 4n square plus 4n 6n plus 4 divided by n square 2 and 2, which n further revised as n plus 2 multiplied by n square plus 2n plus 2 divided by n square plus 2 plus 2. This is cancelled, so we come out with 10 inverse plus 2, which can also be written as inverse of n plus 1 plus 1. This is what we needed to do in the part that argument of wn plus 1 will be equal to 10 inverse n plus 1 plus 1. So this is what we have got, 10 inverse n plus 1 plus 1. So we have also the solutions. We have already proved that the argument of w1 is 10 inverse 2 and 10 inverse a plus b equals 10 inverse a plus b upon 1 minus ab. For such similar questions, do visit our website www.academy.com and register explanations. Thank you.